Hello everyone. Today we are going to learn about X-ray diffraction, commonly called XRD. XRD is one of the most important characterization techniques used in nanoscience and material science. It helps us understand how atoms are arranged inside a material. In this lecture, we will learn what X-ray is, how diffraction occurs, how XRD works, and where XRD is used in real life. Outline of this lecture. In this session, we will cover introduction to X-rays and XRD, history of X-ray diffraction, components and working principle, Bragg's law, powder XRD and single crystal XRD, and application of XRD. Let us start with the basics. X-ray diffraction is a fundamental analytical technique used to study crystalline solid. It is very important because it tells us the crystal structure of material. It is widely used in physics, chemistry, biology, and medicine. Even complex biological molecules like DNA were studied using XRD. So XRD acts as bridge between chemistry and biology. XRD used in many fields such as solid state physics, biophysics, medical physics, chemistry, and biochemistry. Whenever we want to know how atoms are arranged in a solid material, XRD is the first choice. What is X-ray? Now let us understand what is X-ray. X-rays are a type of electromagnetic radiation just like visible light. However, X-rays have much shorter wavelength, much higher energy, high penetrating power. Because of their wavelength is similar to spacing between atoms, X-rays are perfect for studying crystal structures. History of X-ray diffraction. Let us briefly look at the history. In 1895, X-rays were discovered by Rankton. In 1914, the first crystal diffraction pattern was observed by Van Loon, and in 1915, Bragg's law was developed, which became foundation of XRD. In 1953, the structure of DNA was discovered using XRD data. Today, the advanced computer detectors have made XRD faster and more accurate. So in this diagram is the first X-ray. X-rays are produced inside the X-ray tube. High-energy electrons are accelerated and made to strike a metal target called anode. Common anode materials include copper, iron. When electrons hit the metal target, X-rays are generated. X-ray diffraction is a non-destructive technique used to analyze crystalline materials. It is commonly used for ceramics, metals and alloys, minerals, inorganic compounds. XRD provides information about crystal structure, unit cell dimension, phase composition. Main components of an XRD instrument. An XRD instrument consists of X-ray source and a sample holder detector to measure diffracted X-rays data processing system. All these components work together to record a diffraction pattern. How XRD works? In XRD, a beam of X-rays is directed onto a crystalline sample. The X-ray interact with the atomic planes inside the crystal. At certain angles, the reflected X-ray combine and produce strongly intensity peaks. These angles correspond to consecutive interference and the pattern is recorded by the detector. Bragg's law explains why diffraction occurs. X-rays reflected from different atomic planes travel different distance. X-rays reflected from different atomic planes travel different distance. When the path difference is equal to whole number of wavelengths, consecutive interference occurs. Bragg law is given by n lambda is equal to 2d sin theta. This equation relates wavelength of X-ray, space between crystal planes, diffraction angle. The diagram shows how X-rays reflect from crystal planes. The key idea is at certain angles, reflected X-rays add together at other angles they cannot cancel out. Only the angles satisfying Bragg's law produce diffraction peaks. Diffraction from a crystal, diffraction from a lattice, diffraction from a unit cell. Single crystal XRD used when a perfect single crystal is available. It gives exact crystal structure, atomic position, crystal orientation, information about defects. The diffraction peaks are very sharp and well separated. XRD has many applications such as determining crystal structure, identifying unknown phases, measuring grain size and strain, studying polymers and fibers, analyzing thin films, studying archaeological material. XRD is widely used in both research and industry. To summarize today's lecture, XRD is a powerful tool for studying crystalline material. It is based on X-ray diffraction and Bragg's law. It provides information about structure, phase, and size. Powder XRD is especially important for nanomaterials. Thank you.